When installing a subpanel in a separate building, it is essential to keep the neutral and ground bars separate. This is a critical safety measure outlined in the National Electrical Code, specifically Section 250.32a. This section addresses grounding and bonding requirements for buildings or structures supplied by a feeder or branch circuit. The steps for installing a subpanel in a separate building while adhering to these safety guidelines are as follows. Firstly, you must remove the bonding strap, sometimes referred to as a bus bar, that connects the neutral and ground bars within the subpanel. This strap creates an electrical connection between the neutral and ground systems, and it is present in most panels as they are typically configured for service entrance applications where the neutral and ground are bonded to a single point. In a subpanel application in a separate building, this bond must be removed to prevent circulating neutral currents from flowing on the grounding conductors. Secondly, you will need to install a separate ground rod at the separate building where the subpanel is located. This ground rod provides a direct connection to earth, which helps to stabilize the voltage to ground and provide a path for fault current to flow back to the source in the event of a ground fault. The ground rod should be at least 8 feet long and driven into the ground until at least 8 feet of its length is in contact with the soil. Local codes may have specific requirements for ground rod installation, so it is important to consult with your local authority having jurisdiction. Thirdly, you must bond the ground bar in the subpanel to the ground rod using a grounding electrode conductor (GEC). This conductor provides the electrical connection between the ground rod and the grounding system of the subpanel. The size of the GEC is determined by National Electrical Code Table 250.66, which specifies the minimum size of the GEC based on the size of the ungrounded conductors feeding the building or structure. For example, if the ungrounded conductors are 2/0 copper or 4/0 aluminum, the grounding electrode conductor must be at least number 4 copper or number 2 aluminum. Fourthly, the neutral bar should not be bonded to the grounding electrode conductor at the subpanel. This is to maintain the separation of the neutral and ground systems. The neutral conductor from the main panel provides the return path for normal circuit current, and it should be isolated from the grounding system in the subpanel. Fifthly, any metallic components, such as a metal tube, should be bonded to the ground bar in the subpanel. This ensures that all metallic parts are at the same electrical potential, which reduces the risk of electric shock. Bonding is achieved by connecting a bonding jumper from the metallic component to the ground bar. The size of the bonding jumper is determined by National Electrical Code Table 250.102 cone, which specifies the minimum size of the bonding jumper based on the size of the circuit conductors supplying the equipment. According to the NEC, the grounding electrode conductor size must adhere to Table 250.66. This table provides specific guidelines based on the size of the ungrounded conductors. For example, if you're using number 2 AWG copper conductors, you'll need a number 6 AWG copper grounding electrode conductor. If you're using 3/0 AWG aluminum conductors, you'll need a number 4 AWG copper grounding electrode conductor. It is crucial to ensure the feeder circuit supplying the subpanel includes both a neutral and a ground conductor. The absence of either can compromise the safety and functionality of the subpanel. The purpose of the neutral conductor is to carry the unbalanced current back to the source, while the ground conductor provides a low impedance path for fault current to flow back to the source, facilitating the operation of overcurrent protective devices like circuit breakers or fuses. The feeder circuit conductors must be protected by overcurrent devices at both the main panel and the subpanel. This ensures that any overcurrent condition, such as a short circuit or overload, will be quickly interrupted, preventing damage to the equipment and reducing the risk of fire. The overcurrent devices should be sized appropriately for the ampacity of the conductors they are protecting. It is also essential to properly label the subpanel to clearly indicate that it is a subpanel. This helps to avoid confusion and ensures that anyone working on the electrical system understands the configuration and grounding scheme. The label should be permanently fixed to the subpanel and should be easily visible. Installing a subpanel involves working with electricity and can be dangerous if not done correctly. It is always recommended to consult with a qualified electrician for the proper installation of a subpanel. A qualified electrician will have the knowledge, skills, and experience to ensure that the subpanel is installed safely and in accordance with all applicable codes and regulations. They can also help you to select the appropriate components and ensure that the electrical system is properly grounded and bonded. Here's a more in-depth look at NEC Section 250.32. Section 250.32 of the National Electrical Code, titled Buildings or Structures Supplied by Feeders or Branch Circuits, provides specific requirements for grounding and bonding in separately derived buildings or structures. This section aims to ensure electrical safety by establishing a clear path for fault currents and minimizing voltage differences between conductive parts. Subsection 250.32 specifically addresses the grounding electrode system at a separate building or structure. It states that a grounding electrode system must be installed at the separate building or structure. This system must be connected to the grounding electrode conductor, which runs back to the main building or structure. The grounding electrode system typically consists of a ground rod, but other options such as a ground ring, metal underground water pipe, or concrete encased electrode are also permitted. The choice of grounding electrode will depend on site conditions and local codes. Subsection 250.32b covers the equipment grounding conductor. It requires that an equipment grounding conductor be run with the feeder or branch circuit that supplies the separate building or structure. This equipment grounding conductor provides a low impedance path for fault current to flow back to the source, which helps to quickly trip over current protective devices and prevent electrical shock. The equipment grounding conductor must be sized according to NEC Table 250.122, which specifies the minimum size of the equipment grounding conductor based on the size of the circuit conductors. Subsection 250.32c addresses the grounded conductor, which is typically the neutral conductor. It states that the grounded conductor must be insulated and must be run with the feeder or branch circuit that supplies the separate building or structure. The grounded conductor provides the return path for normal circuit current, and it must be sized according to NEC Section 220.61, which specifies the minimum size of the grounded conductor based on the unbalanced load. Subsection 250.32d provides specific requirements for bonding at the separate building or structure. It requires that all metal parts that are likely to become energized be bonded together and connected to the grounding electrode system. This includes metal water pipes, metal gas pipes, metal siding, and metal roofing. Bonding helps to ensure that all metal parts are at the same electrical potential, which reduces the risk of electric shock. The bonding jumpers must be sized according to NEC Table 250.102 cone, which specifies the minimum size of the bonding jumper based on the size of the circuit conductors. Subsection 250.32e addresses the use of ground fault circuit interrupters, GFCIs. It requires that GFCIs be installed in certain locations at the separate building or structure, such as bathrooms, kitchens, and outdoor areas. GFCIs are designed to detect small amounts of current leakage to ground and quickly interrupt the circuit, which can prevent electrical shock. Understanding and complying with NEC Section 250.32 is essential for ensuring electrical safety in separately derived buildings or structures. By following the requirements in this section, you can create a safe and reliable electrical system that protects people and property from electrical hazards. Also, consider the impact of voltage drop on the conductors feeding the subpanel. Longer runs of cable will experience greater voltage drop, which can affect the performance of equipment connected to the subpanel. To mitigate voltage drop, you may need to increase the size of the conductors. Consult NEC Chapter 9, Table 8 for conductor properties and voltage drop calculations. Furthermore, surge protection is an important consideration for subpanels in separate buildings. Surges can enter the electrical system through the feeder conductors or through the grounding electrode system. Installing a surge protective device, SPD, at the subpanel can help to protect sensitive electronic equipment from damage caused by surges. Choose an SPD with an appropriate voltage rating and surge current capacity for the application. When selecting a location for the subpanel, consider factors such as accessibility, environmental conditions, and the proximity to the loads it will serve. The subpanel should be located in a dry, well-ventilated area that is easily accessible for maintenance and repairs. Avoid locations that are exposed to moisture, dust, or extreme temperatures. The subpanel should also be located as close as possible to the loads it will serve to minimize voltage drop and conductor length. Before starting any electrical work, always disconnect the power to the circuit at the main panel. Use a voltage tester to verify that the circuit is energized before touching any wires or components. Wear appropriate personal protective equipment, such as safety glasses and insulated gloves. Work carefully and methodically, and double-check your work to ensure that everything is connected correctly. Finally, remember that electrical codes and regulations can vary depending on your location. Always consult with your local authority having jurisdiction to ensure that you are complying with all applicable requirements.